All right, guys, so today we're going to talk about the logarithm. So, hey, I'm talking to them now, which is you in the future. A logarithm is another way of writing exponents. So the very first thing we need to talk about is the fact that the logarithm and the exponential equation are inverses. So our first formula, it's not really a formula, it's just a different way to write it, comes from the fact that they're inverses. Remember, they're inverse, you swap the x and the y. Well, here we go. If we swap things up in here, b raised to the x power is a. So because they're inverses, this is true. Now let's talk about the parts of this logarithm. Right here, that's the base. Okay. Over here, this a right here, that's called your argument. Yeah, it's like that thing you lose all the time, argument. All right, so that's the parts of the logarithm. Makes you know, makes you understand this formula. You're literally just going to rewrite these things. All right, so if we have log base 3 of 9 equals 2, we can rewrite that in exponential form as 3 to the second power equals 9. 6 to the third power equals 216. We're literally just going to rewrite these guys. 7 to the 0 is 1. Hey, wait, is that true? Yep, anything to the 0 power is 1. 2 to the 4th power is 16. 4 to the negative 2, sure, is 1/16. So what we did here was we reciprocated and squared it. So 4 squared is 16, flip it, 1/16. 9 to the 3 halves, well, let's check it out. It's equal to 27 apparently. Remember, your denominator is your root, so that's the second root of 9. Square root of 9 is 3. 3 to the third power is 27. Checks out. Of course, you can use this guy, which we'll be relying on a lot in a minute. We can go the other way around too. Our base is 14, so we're going to do log with a base of 14. Our arguments over here on the other side of the equal sign equals 2. So it's important to realize that logs are exponents. The logarithm equals your exponent here, right? So tomorrow, whenever we get to properties of logarithms, you'll see how that goes. Same thing, whenever we raise a power to a power, we're going to be multiplying. We multiply exponents, we add them. We'll see how that affects our logs. For now, though, just doing the basics. Log base 3 of 81 is 4. Log base 12 of 12 is 1. Sure enough, 12 to the first power is 1. Log base 36 of 6 is a half. So notice here, if our base is bigger than our argument, we're going to have something that's less than 1 here. Now, I'm not going to the negatives because that would just indicate reciprocating. So log base 2 of an 8 is negative 3. Okay. All right, right here. Log base 8, argument 16 is 4/3. So all you got to do is practice, guys. There's nothing much to do but practice these. Just rewrite from log to exponent, exponent to log. We're going to use that later to solve equations, so be prepared. There's 2 special bases you got to know. If you got a straight log, that means log with a base of 10. We call that the common log. If we have ln, that's the same as log with a base of e. We call that the natural log. The reason it's ln and not nl, the dude that made this wasn't American. Yeah, you can figure it out from there. All right, let's check it out. We got log base 7 of 49. Well, what's that equal to? I'm not sure. That's equal to something. So I'm going to write out this one, but the rest we're just going to pretty much do in our heads. 7 to some power is equal to 49. Oh, hey. 7 to what power is 49? 2. And that's all you got to do to think about these things. 3 to what power is 27? The third power. Oh, what about this log right here? Remember, that's understood base of 10. 10 to what power is 100? 2. 12 to what power is 1? 0. 2 to what power is 64? Well, if you don't know that it's 6, you can take your calculator. 2, what's the power? Well, let's see, that's a 32. Let's see, 2 to the 6th power. Oh, there we go, 64, yes, yes. 3 to the 5th power is 243. All right, we got a fraction going on, so we know we need a negative. 9 to 81, that's a 2, so that's negative 2. 64 to 4, that's getting smaller, so I need a fraction. The cube root of 64 is 4 because 4 to the third is 64, right? That's a third. You can check it out if you don't believe me. 64 to the 1/3 power, sure enough, is 4. Now, if you have this calculator, you don't have to worry so much about this formula. If you don't have this calculator, this formula will save your life. To go from log base b of a, that is some random base, since a lot of calculators only have this log button and this ln button. They don't have this handy little button right here. You take log of your argument divided by log of your base. Once you do that, you can convert to these guys. So let's do this one. Now, if you have the Casio FX15ES Plus, you can hit this button right here and type in your base and argument. You get 3/2. Let's do the same problem, but using the change of base formula. So let's say, I don't have that open, do I? No, okay, whatever. Let's pretend we don't have this button. Then we do log of our argument over or divided by log of our base. 3/2, same thing. Let's check this next one. Log of 32 divided by log of 8. That's going to give us 5/3. Doesn't matter if you use the division or the fraction, because fractions are just division problems. And if you have this calculator, feel free to just type it in. 5/3. So log, I don't want to do it that way. Let me do it this way. Log base 2 of 54. Now, if you get a decimal, I'm going to want you to round it to 4 decimal places. Round it to 4 decimal places. So right here, 8. Let's look at the next number. That's an 8. Makes it the next number right here go up. So that's 5.7549. When you get to college, you're going to be typing these answers in a computer. If you round wrong, you get the answer wrong. Don't round wrong. Log base 10. Oh, hey, why don't I just do this? Remember, log, straight log, is just log base 10. So that's 2.4683. Here, log base 4, 136, 3.5437. So this is a 3 here, believe it or not. Oh, this is -2, right? 6 and 1 over 36. It's a fraction, so we're going to reciprocate it. That's a negative. 6 to 36, that's squared. And that's it, guys. Nice and easy lesson. Do the practice. Tomorrow, we're going to learn how to use these properties of logarithms. So practice these so you know how to deal with these guys. See ya.